Everybody, we have an integer cubic equation, and everything inside is integer, so it makes sense to figure out the prime factorization, which takes a little bit of time to determine that 589 is equal to 19 times 31. Okay. Again, y'all, all we're looking for here is find all the integers in that satisfy this. You don't have to find the x, y's, and z's. Okay. So the tendency is to expand this out, bring the 589 to the other side, and then try to turn it to a cubic and factor. That's not the way to go here. We're looking for integer solutions, namely just n. We don't care about x, y, and z. We do know the sum of x, y, and z is 48. Okay. Now the big observation that I didn't see for the longest time is to note that if you sum up each of these individual factors, you get 3n minus x plus y plus z. But notice that each of these individual factors have to be factors of 589. And so I says it equals the sum of the divisors of 589. Should have written that in. That's what that means. 589. You see, the fact that 589 is almost prime itself is quite helpful here. Okay, so let's move along. Now, it's about just spreading out the divisors. Notice that 1 is a default divisor of any integer, right? So we have to look at all these possibilities, including these negative pair possibilities. Now, if you consider just the positive factors first, you actually get a solution here. Okay, again, we're given that 48 is equal to this sum. That's where you get this 48 right here. When you add to this and divide by 3, you get n equals 33. So right off the bat, we get n equals 33 as a solution. Again, notice we're not interested in the value. We could go through, you could find the x, y's, and z's if you want, but didn't ask for that. Okay. Now, notice how we have to shift things around a little bit in terms of the minus signs, because a minus times a minus, of course, is a plus, and that creates this additional complication here. Now, notice that minus 1 plus minus 19 plus 31 is the 11 that you see right here. You see the 51 that you saw right here was 31 plus 19 plus 1, right? Right here you have minus minus, but this still gives you a positive 589, but you have to consider it, right? And when you do that, you get this number here, which is not, okay, it's not an integer, obviously, right? And we are looking for integer solutions, okay? Now, in a similar fashion, folks, I'm not going to go through all the cases here, but you could spread the minus 1 to here, right? You could leave this as a minus 1, turn this to a 19, and then turn this guy right here to minus 31, right? And again, you guys can do the work if you want to, but you'll get that n is, I should say, not a member of z right there, right? You'll get right here, you'll get n is not a member of z. Okay, for that case. And again, the work isn't too difficult. It's very similar to what I did. And then what's the last possibility? We can leave this as what, 1 and make the last two minus. So for you, if you make the last two negative, okay, you get n is not a member of z also. I don't know why I can't write that down. N is not a member of z, if that's how you negate membership. Maybe it's the slash goes the other way, I don't know. Okay, so far this is the only solution we have. Now, an easy case to overlook is this very last case here, where you actually write down 1, 1 in 589. That's a possibility, right? That's a possibility. And so what does that lead to? This sums up to 601, right? Is that, no, 591. So that would sum up to 591. And let's see, that says that 3n is equal to, whatever this number is it 5, is it 639? 3n is equal to 639. And that, you can tell that's divisible by 3 by the sum of the digits. 9 plus 3 plus 6 is 18, divisible by 3, right? And so that would mean that n is equal to, what can I do that one in my head? Let's see, I should be able to. 213. 213. Okay, so that's an other case. Now, y'all, again, you can move these. There's two other cases here that involve, like last time, you could have -1, -1, right? And there's a few other cases here. Let's see, what would be another one? I guess there's only one other case here. You could have, let's see, you could have -1, 1 and 5, and -589. And I guess those are the only other cases. But again, in a similar fashion, for these cases, you'll get n is not a member of z. In other words, it's just a healthy fraction, right? Okay, and so anyway, this, of course, I'll say it for emphasis, superfluous, but it is a member of z. And also right here, this n is a member of z. Okay? So those are the only two solutions that I got, folks. I made a mistake on the last video, somebody pointed out, but I'm pretty sure, I'm not positive, but I'm fairly certain, that these are the only two solutions to the problem. N equals 33 and n is equal to 213. So we'll write that if you want to, for summary purposes. 33 and 213 are the only solutions that I found. Okay, so. Okay. Thanks for viewing.